Welcome with AI with Izzy. And this week, I'm going to walk you through XGBoost, one of my favorite machine learning models under the regression classes. Um, this week is going to be quite different in terms of how I'm going to project XGBoost in comparison to random forest tree regression. However, the same principles apply. We're looking at the same data, we're looking at the same hypothesis. You want to figure out market value influences. So stay on track, and again, stay living with AI. As an additional note, I just want to say thank you to everyone who showed love during my journey in machine learning. Stick around, there's loads more fun data sets for me to walk through, so much more fun classifications that I need to show you in machine learning. So stay tuned, there'll be a lot more coming your way, all in sports. So stay living in AI. Peace. Let's talk about XGBoost. Again, one of my favorite kind of models in machine learning that I love to kind of use and leverage quite often. Um, just because I just love how intuitive, very easy it is to learn and grasp, as well as how powerful the results can be. Um, very, very similar approach to random forest tree regression. Butchered that name so many times. But again, yeah, I just want to walk you through kind of the thought and process here. So same thing as what you've seen in the previous video regarding the data set. I've added 2 extra feature engineering that kind of helped improve the R2 score. And here I've basically just replaced and removed like any nons and things like that. So again, you'll see later on down how it's really important to always go back to like log in your data. What I mean by that is just triple check and make sure that it's actually clean enough to actually work in the model before you even put it in front of the model. And how you can see the feature scale, the feature engineering. I was going to say feature scaling, feature engineering. So you got goals per minute, goals contribution per minute as well, which has been included in there. The one caveat is I'm actually focusing on players that's basically had more than 0 of minutes played. And then if you scroll down a bit, you've got the one hot encoder, same thing as before, the position. Here I'm basically training the data. So we've got xtrain, xtest, xencoded. I'm sticking to my 0.2, 20% of the x data, basically xtest. I want the test size to be 20%. And then here, I'm actually calling the XGB. Remember before we imported the XGBoost. Here I'm actually calling XGB in here, and I'm actually setting the same estimators to 300. And then here comes the fun part, right? Which is y_pred is here. I'm actually predicting the actual model. So again, the X test that we called, the 20%, now predict based on that 20% of data that I've given you. Here you go, predict and show me what the market value should be. Here the R2 score and the squared mean error. I'm gonna butcher it again. Damn. Mean squared error. Sorry, mean squared error. I am human, not a robot. Mean squared error. Basically, what that means is we've got a lot less than what we had from the random forest tree regression, but the actual overall score was a lot less, so 48%, which again doesn't give me much confidence that the model was able to predict as much or as fairly as possible as the random forest tree was able to. So that will be the slight nuances there that, again, when it comes to machine learning and you're trying to test different models, this is probably the best way to figure out which ones perform best and which one hasn't based off the R2 score. And that also gives you the sense or the feeling sense of relief that, okay, my model's working as correct as it should be because I've tested 3 or 4 models. I went on thinking, one model's enough, but as I start to learn different models, listen to different tutors and listen to different mentors, you have to test at least 3 or 4 different models to come to an actual conclusion. So that really does help. And then here I like to visualize the data. So again, similarly, it's quite different to what you would see in the random forest tree regression, but you can see there's like significant outliers here. And that concerns me, which is, as compared to the random forest tree where they were a lot more aligned to the linear line that we saw. Here you've got a few that are just absolutely just outskirts. And again, that's a worry, especially in machine learning. So hope you like the XGBoost kind of walkthrough. The next one will be the decision tree. Promise not to butcher that name, but thank you for tuning in. And any comments below, for them in. Anything that you think that you saw that I could have done better on, please let me know. But yeah, this has been XGBoost. Nice name, by the way, XGBoost. All right, cool. So as you've just seen, I was walking through XGBoost, and to predict a Premier League players market, especially in today's world, is so much difficult. There's so much nuances that go into it on the pitch as well as off the pitch. So far, we've seen XGBoost deliver around 48%. Again, not bad, but also not great, especially not at the threshold that we want to be at. So, although XGBoost is one of my favorites, I just need to add more feature engineering, make sure there's no more outliers, to ensure that I'm collecting the most amount of data to feed into the machine learning model. This is just one part of the test. There's going to be loads more to come. And definitely one thing to look out for is my aim and my passion is to literally find a model with all the right data set that I can upload into it to get me at least an R2 score of above 90%. And that's where I feel more comfortable understanding and knowing that I've truly built a machine learning model that can effectively perform and dictate and actually learn what the market value of a football player should be in the Premier League, of course. Hope you really enjoyed the video. Tune in for more next week. We'll jump into something different, a different model, but the same data set. And the reason I'm doing this is just to make sure that you all are familiarized with the different various machine learning models that are there. And the importance of, like I said in my earlier videos, is you have to test various amount of models and also check the R2 score. That then gives you whether or not which model is the most closest to the 90, and then also how you can tweak it to effectively get you to 90. So thank you so much for joining me in my journey in machine learning. Hope you're all having fun and stay living with AI. Peace.